Hello student, now we'll see introduction of ADC. What is mean by ADC? ADC is analog to digital converter. These are generally used in control operation and instrumentation in industries. ADC are used everywhere when we have to process, store or transmit an analog signal in digital form. Basically, ADC converts are mostly used device for data acquisition. What is mean by data acquisition? It is signal conversion and make it understandable to microcontroller or microprocessor. Everyone knows computer use binary value, but in physical world everything is analog. In physical world means what? Like in around us, temperature, pressure, humidity, light, force, these are the physical quantities which are having analog values. Like temperature, it's degree Celsius or Fahrenheit. Light, we measure in lux. Then pressure is in Pascal or kilopascal. Then force, kg or kilonewton. So these physical quantity is converted to electrical signal using device called transducer. Everyone knows this transducer is nothing but sensor. This sensor converts electrical signal. This sensors converts physical quantity into electrical signals. Example, voltage, current or resistance. For example, temperature sensor, it converts temperature into either in voltage or in resistance. Like pressure sensor, it converts pressure kilopascal into some millivolt. Light, lux, the output is in the form of either resistance, we know LDR, light dependent resistor. Then it converts light into current, it converts light into voltage. So we need an analog to digital converter to translate analog signal to digital numbers so that microcontroller can read and process. See, these all physical quantities come with analog value, but we know microcontroller or microprocessor knows binary value or digital value. So make it understandable, we have to convert first this analog value into digital value, and again for the display we have to convert the digital value into analog value. In some of the microcontroller, the manufacturer are not given ADC inbuilt. What is mean ADC inbuilt? The ADC configuration is inbuilt itself, but some microcontrollers are not coming with inbuilt ADC. We have to connect external IC to microcontroller or microprocessor like 0808. It is ADC, external ADC IC. We have to interface this ADC with microcontroller. But in PIC microcontroller, we are having 10-bit inbuilt ADC. Types of ADC. In our digital electronics subject, we have already studied these A to D converters, flash AT2 converters, successive approximation converters, we abbreviated as a SARS, successive approximation. Examples of successive approximations are dual slope and delta sigma. We are not going to deep into this topic. Then an ADC converts a continuous time and continuous amplitude analog signal to discrete time and discrete amplitude digital signal. How? Here one block diagram is there. This is sample and hold circuit. This is sample and hold circuit, but it is called as a sample and hold circuit because it samples the signal by using switch and hold for a moment. If you give a sine wave or any analog signal, this switch, if I turn on this switch or close this switch, what happen? This capacitor start charging. Then when switch is open or turn off the switch, then capacitor discharge through the load. This is called as a sampling and hold circuit. This switch, it may be IGBT, it may be MOSFET, it may be your clock pulse, external clock pulse. So for that time the capacitor will hold this analog signal, and when it on off the switch, then capacitor start discharge. So for that movement, here you can see it is charge, capacitor hold for a moment, again it discharge, hold for a moment. So it will give the discrete kind of signal. Then quantization, what is mean by quantization? Is the process where the least significant bit determine if the input analog voltage lies in the lowest sub-range of input voltage range. The quantization means it converts that sample and hold circuit's output with some fixed digital value. In sample and hold circuit, they first sample the signal, then quantify it, it determine the resolution of signal, and finally get the binary values and send it to the system to read the digital value. First it convert it into digital form and send it to the microcontroller or microprocessor for the further process. Here you can find out one analog signal is given, and one analog signal, this blue line is analog signal, and this red waveform is digital form. For example, if I take one example, 2 volt is V in is here, ADC input is 2 volt. The resolution of ADC is 3 bit. That means how many levels it will give you, or it will break the signal. This 2 volt will break into 2 raised to 3. That means it is equal to 8. So this 2 volt 0 to 2 will break with 8 levels. So resolution is of 3 bits, number of levels are 8. So your signal will divide into 8 levels. The first range means at 0 voltage it will show is 0 0 0. What about the higher value? So the step size or difference between two level is here, or I'll take this. How to calculate this level? This is nothing but your voltage level. Here the first 0 will be 0 voltage. The step size is how much? It is 250 millivolt how it comes. This 2 divided by 8, it will give 250 millivolt. So the difference between two value is 250 millivolt. If any range between 0 to 250 millivolt will show 00. If input Vn comes between any value of 0 to 250, it will give output 000. If it is above 250, the next step will be 250 to 500 millivolt. It will give 0, 0, 1. It will give 0, 0, 1. So any value come between these two range, it will give digital output 0, 0, 1. Thank you, student.